The coding phase in the product development lifecycle is the stage where the actual software product begins to take shape. It is the phase following design and planning, where the abstract ideas, designs, and specifications are converted into functional code. This is often considered the most critical phase because the quality, efficiency, and maintainability of the final product largely depend on how the coding is executed. During this phase, developers start by setting up the development environment. This includes installing necessary tools, frameworks, and libraries, as well as configuring version control systems like Git. A properly configured environment ensures that all developers can work consistently and helps prevent integration issues later on in the cycle. The next step is writing the actual code according to the specifications outlined during the design phase. Developers follow coding standards and guidelines to maintain consistency across the team. These standards cover naming conventions, commenting practices, and modularity, which are crucial for long-term maintenance and collaboration. Code is typically divided into modules or components to simplify development and testing. Each module is designed to handle specific functionality. For example, in an e-commerce application, there might be separate modules for user authentication, product management, payment processing, and order tracking. This modular approach helps in isolating issues and allows multiple developers to work in parallel. During coding, developers frequently perform unit testing to ensure each module works as intended. Unit testing involves checking individual functions or classes for correctness, and automated testing frameworks are often employed to make this process faster and more reliable. Early testing helps in detecting bugs before they pop in propagate into more complex issues. Version control plays a vital role during the coding phase. Developers regularly commit their code to repositories and create branches for new features or bug fixes. This allows teams to collaborate efficiently, track changes, and roll back to previous versions if something goes wrong. Tools like GitHub, GitLab, and Bitbucket are commonly used for this purpose. Code reviews are another essential activity in this phase. Developers review each other's code to identify potential issues, suggest improvements, and ensure adherence to standards. Code reviews help in maintaining code quality, sharing knowledge across the team, and preventing the introduction of security vulnerabilities. Integration of different modules is done gradually as coding progresses. Integration testing ensures that the combined modules work correctly together. Continuous integration tools, such as Jenkins, Travis CI, or Circle CI, automate this process, making it easier to detect integration errors early and reduce the risk of major defects during later stages. Throughout the coding phase, proper documentation is maintained. This includes inline comments, README files, and technical documentation that describe the code's functionality, usage, and limitations. Good documentation is essential for future maintenance, onboarding new developers, and troubleshooting issues after deployment. The coding phase also emphasizes performance optimization. Developers identify and fix bottlenecks, optimize algorithms, and ensure that the software meets performance benchmarks. Security considerations are addressed by implementing safe coding practices, validating inputs, and safeguarding against common vulnerabilities like SQL injection or cross-site scripting. Finally, the coding phase concludes when the software has been fully implemented and initial testing confirms that it meets the specified requirements. At this point, the product moves into the testing phase of the PDLC, where more extensive system integration and user acceptance tests are conducted. Successful coding sets a strong foundation for a reliable and maintainable product.